Hello friends, I'm Jane Jaiswal and today we are going to learn how to calculate time complexity of merge sort algorithm. Before getting right into it, let's understand how does the merge sort algorithm work. Merge sort algorithm uses divide and conquer strategy where it splits up the problem into different subproblems, creates the solution, and then combines the solution to give out the final result. During the merge sort algorithm, let's say we have an example of unsorted array like this. During the merge sort algorithm, we'll split the array into subarrays, apply merge sort algorithm on the subarrays recursively, get the sorted array, and merge the sorted arrays to get the final result. We'll recursively split during the merge sort algorithm. We'll recursively split the subarrays until we reach a point where the subarray contains only one element because any array with only one element is always sorted. Once we have reached this point, we'll start combining the results of the subarrays and merge them together to form larger sorted subarrays. We'll keep on doing this until we get our final sorted array, much like this. Now let us understand how the time complexity is calculated for merge sort algorithm. For n elements, the total time taken to sort the elements is T of n, is basically the sum of time taken to sort the subarrays plus time taken to merge the sorted subarrays. So the time taken to sort the subarray is T of n by 2, whereas the time taken to merge these two sorted subarrays is M of n. Now, time taken to sort the two subarrays can be basically done in a linear amount of time. Hence, M of n is C times n, where C is some constant. Now, we want to get T of n in terms of T of 1, which is basically a unit time, and the number of elements n. To do this, we'll start by substituting T of n by 2 in terms of T of n by 4, and we'll see what happens. Twice of T of n by 4 plus Cn by 2 plus Cn. This will be 4 times T of n by 4 plus twice of Cn, like this. We can again substitute T of n by 4 in terms of T of n by 8. And doing the calculation, we get the result is. Here we are seeing a pattern. For the coefficient 3, for T of n by 8, 8 is also 2 power 3. Whereas the coefficient of T of n by 8 is also 2 power 3. Here, for coefficient of Cn is 2. Ti of n by 4 is T of n by 2 square. And coefficient of T of n by 4 is also 2 square. In our main equation also, the coefficient of Cn is 1. Whereas we have 2 of n by 2 power 1. And the coefficient of T of n by 2 is 2 power 1. So let's suppose we have done this k times operation. So we can, by pattern, we can say that it will be 2 power k T of n upon 2 power k plus k times Cn. Result will be like this. Now, for the worst case scenario, maximum number of splits can occur when the number of elements in array are of the power of 2. So we can let's assume that number of elements equal to 2 power k, n equals to 2 power k. So for the worst case scenario, we know n equals to 2 power k. So n by 2 power k equals to 1. And taking log on both sides, we have k equals to n log base of 2. So using this results in the final equation, we get T of n equals to n times T of 1 plus C times n log n. Now the first term, T of 1 is a unit time and constant. So the first term is of the order of big O of n. The second term is C times n log n. So it's of the order of big O of n log n. Hence the final time taken is of the order of big O of n log n. Hence, we can say that the time complexity of merge sort algorithm, worst case time complexity of the merge sort algorithm is of the order of big O of n log n. Thank you for being with me.